Hey scientists, Scientist Global here. Today we're going to be talking about what scientists look like. What do you think a scientist looks like? Let's take a look at some examples of some scientists that we see in movies, on your TV show, and even on YouTube. Take a look. Now, did that match what you normally think of when you think of a scientist? I'm about to show you what some real scientists look like. Take a look at these and meet real scientists. Wow, so cool. They didn't look like anything in the picture that we showed the beginning at what we usually see on TV and in the movies. I have one more scientist to show you. Go look in the mirror and see what you see. A scientist, exactly. Even in third grade, you can be a scientist. Here's what we're going to be doing today. I need you to take out your science jacket. This is going to be your science coat, just like Mrs. Goebel wears her science coat. And you are going to design your own lab coat. You can put on here whatever you like. So if you are a big gamer and you want to put on Fortnite, you may put on some Fortnite. If you love Roblox, put it on here. If you love Barbies, put a Barbie on here. Whatever you like, this is your science coat. Design it for you. Make sure you take a picture and send it to your teacher because we would love to see it. We are going to be learning 2 science vocabulary terms today. The first one is hypothesis. Now, a hypothesis is an educated guess or an educated prediction. Based on everything that we already know, we are making a prediction or a guess at what might happen. Our second one is observation. Now, an observation is when you're watching something to learn from it. That is called an observation. We do those 2 things all the time in science. Now, let's get started with our first experiment. Have you ever noticed on a rainy days how H2O, also known as water, forms droplets on a window? I have. Have you ever spilt water on a table and noticed that the liquid sticks up a little bit and doesn't lay flat or even out on the surface? Why doesn't it even out on the surface? I'm not sure. This actually happens because of surface tension. Surface tension is when liquid surfaces to shrink into the minimum surface area so it doesn't spread out. All of these H2O or water molecules are attracted to one another, kind of like magnets, and they stick together. Here is an example and an experiment of how we can show surface tension. For this experiment, you're going to need to get your dropper out. You need a penny and you need some water. Tap water is just fine out of the sink, okay? Now you're gonna lay your penny on a clean, dry surface. It needs to be flat. And we are going to first make a prediction or hypothesis about what we think is gonna happen if we squeeze water into our droplet and we start dropping water onto our penny. What do you think might happen? How many drops are gonna get on there before it spills over? Let's try. 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm only counting the drops that are going on my penny right now. 10, 11, 12, 13, 14, 15, 16, 17. Okay, it still hasn't spilled yet. When you're doing this experiment, get down to eye level of the penny and check it out. I can see the water. It's staying on the penny. Keep dropping that water on the penny until it actually spills over. See how many drops you're able to get. This is observation. We are watching to learn all about surface tension. All right, now I understand that water likes to stick together like magnets, right? But sometimes when we're washing clothes, you know, like when we like to jump in muddy puddles or get dirty on the playground or at a sports practice, our clothes get dirty. Well, in order to wash these dirty clothes, the water needs to cover more of an area than just a little penny, right? So how can I get the water to separate? How can I got it. I need to decrease the surface tension. Right here, the surface tension makes the water molecules stick together like magnets, but I need to decrease it and try to break apart those water molecules. Here's an experiment on how we can show you how to decrease surface tension. Now, hypothesis, my educated guess. Knowing what already happened with my penny on the regular water, what's going to happen if we use soapy water? Go ahead and get some soap, put it into your water. I'm going to mix it up a little bit. All right, I have no water left in my dropper. I am now going to take some water from the soapy water dish. All right, oh yeah, that's nice and soapy. I'm gonna take a paper towel and clean off my penny. How many drops do you think we're gonna be able to get on this penny with the water and soap liquid? That's your hypothesis. What is your educated guess? Do you think it's gonna be as much as the regular water or less or more? Let's try and find out. 1, 2, 3, 4, 5, 6, 7, 8, 9. I only got to 9 and mine already spilled out. That's because soap acts as a way to decrease that surface tension. It mixes in with that water and now the water can't be attracted together because there's soap all in the way. It's like taking two magnets and putting your hand between it. They're harder to stick together because something's in the way. That's what the soap's doing. It's getting in the way. Now it's your turn. Go ahead and try it with the soapy water and see, observe how your experiment goes. Thank you so much for joining me today, learning all about what real scientists look like and what real scientists use as some of their vocabulary. Experiments are always a fun example, but we need to make sure that we clean up. So please clean up accordingly where you're at in your lab. And we'll see you next time. Bye.